guys, and welcome back to the ACE Academy. In this video, we'll be looking at Ohm's law. I will be introducing this concept to you guys, and we are going to be looking at the relationship between voltage, current, and resistance. In the first video in this video series, I introduced you guys to a couple of components, one of them in particular being the resistor. And we said that the resistor has the ability to oppose current. And we measure this ability using the unit of resistance, which is denoted by the symbol ohm. Okay, this is the law that governs the relationship between resistance, voltage, and current. This was discovered by a scientist back in the day, and this relationship holds great importance to the way in which we work with electric circuits. So, quite simply, the definition for Ohm's law is that the resistance of a conductor or a component is directly proportional to the voltage across its terminals and inversely proportional to the current that flows through the conductor. This is extremely important because it allows us to derive a mathematical relationship for this law, for this concept. And that is that the resistance of any conductor or component is equal to the voltage across the terminals of the conductor divided by the current that passes through the resistor. We are able to take this equation and distribute it and manipulate it in order to obtain two new equations that fulfill the same purpose. And that is, if I manipulate this equation to make V the subject of the formula, I would obtain the equation of V is equal to I times R, which is voltage, is equal to current times resistance. And if I manipulate it further, I would get the equation I is equal to V over R. In order for us to work with these equations quite easily and for us to remember it, we can create a triangle with these three values. And it would look something like this. Okay. So if we wanted to find the current going through a component, we just have to cover I over there and it would give us the equation V over R. If we were wanting to find the resistance of a component, we just cover the R on this side and it will give us the equation V over I. If we wanted to find the voltage, we'll just cover the V on the top and it would give us the equation I times R. It's quite simple, guys. The triangle comes in handy a lot. Okay. If we are moving further, we are now going to look at this little diagram that I have on your screen. And as you guys can see, there is a resistor. Across the resistor is a voltmeter measuring the voltage. And we have a ammeter connected in series to measure the current flowing through the resistor. Let's go ahead and work on a few scenarios just so that you guys are a bit more comfortable working with this law. If the voltage across this connection was 12 volts, I got a 12 volt reading from my voltmeter, and if the amperage or the current passing through this resistor was 3 amperes, and I asked you to find the resistance, all you would have to do is say R is equal to V over I, and manipulating inwards, I would get 12 divided by 3, which is then equal to 4. So the resistance of this resistor is 4 ohms. If I were to give you a different scenario, and in this scenario we would say that the current is 2.4 amperes and the resistance is 10 ohms, I would now want to find the voltage. In order for me to find the voltage, I would just cover up the V on top and I would get the equation V is equal to IR. So let's do that quickly. V is equal to IR. Substituting in my values, I would get 2.4 times 10, and that would give me 24 volts. The voltage across this resistor is 24 volts. If I were to give you a new scenario, and in this scenario, we would have a voltage across the resistor being 3 volts and a resistance of 2 ohms, I would now be able to calculate the current. By covering the I in a triangle, I would obtain the equation I is equal to V over R. And if I substitute in my values, I would get 3 over 2. Therefore, the current should be equal to 1.5 amperes. It's quite simple. The relationship between current, voltage, and resistance is quite easy to understand, guys. This is a very core concept. I want you guys to take a moment to grasp this. It's not too difficult, but if you can master it now, it would make your life much easier when working with electric circuits in grade 10, 11, and 12. That's it for me, guys. All the best, and I will see you in the next one.